Just paste a product listing URL into this automation and watch the flat catalog photos come to life. This workflow turns still images on any fashion e-commerce page into short model videos showing the fit, the drape, the walk, ready for product detail pages, collections, and ads. With millions of online stores chasing higher conversion rates, this is a plug and play upgrade brands will actually pay for. In this video, I'll show you the exact build in n8n using Google's Veo 3.1 model. We're running through a quick demo first, then a node-by-node breakdown with Lucas. Stick around to the end to grab the free template. All right, let's jump in. All right. Jumping into a demo of this automation. What we're gonna do is we're gonna start on this form trigger, which we can go to really any collections page of any e-commerce website. Here we'll do kind of this women's puffer section on the North Face website, and we'll just copy and we'll bring that URL into the automation. And that's all that's needed to kickstart this automation. And now what's gonna happen is first Firecrawl is gonna scrape all of the product photos from each of these individual listings. So after Firecrawl scrapes the relevant images, it'll upload them into this Google Drive folder. And so we can see the source image, the first one, as it loops through, has snagged from the site. It'll upload it into this Google Drive folder. And then we'll pass it into Google's Veo 3 generation model, and we can see the prompt that we're passing. Very simple, generated video that's going to be featured on a product page of an e-commerce store, constraints, yada yada. And so we'll pass that prompt with the image off to Veo 3. We'll wait, and then we can see it'll upload it back to that Google Drive folder, and here it is. And you'll see the model will now have, come to life, strike a couple poses, and finish and end in the exact same frame of the photo that we passed to it. So the effect will be motion on the collections pages and the product image pages of the e-commerce sites that we run this automation on. If you want to download this exact automation and bring it into your n8n, you can get it for free in our school community, AI Automation Mastery, completely free to join. You'll just simply join, navigate to the n8n sections templates, and then you can download the JSON for the automation that you want to snag. Thousands of other AI experts and learners are in this community learning how to build these types of automations. And with that, let's dive into the node by node breakdown, detailing exactly how this automation is built with Lucas.
Let's get started here with a system overview for our Veo 3.1 e-commerce product photo animator. Like what we covered in the demo, the first input and trigger to this whole system is going to be taking in a product catalog URL as input. So once again, on that North Face website, if I come to our women's puffer jacket section, this is what I'm talking about as our input here for a product collection. Now, the thing I want to mention is on a real production automation, you're probably not going to be operating this way where you input a public facing URL. If you're building this for a client on a real e-commerce brand or a D2C brand, there's likely going to be some other connection you're setting up with a backend into their system. This could be something like hooking into their CMS, the Shopify API, or maybe some other kind of bespoke integration to be able to pull out all of that product information. But since we're not partnered right now with the North Face, we're just going to go ahead and scrape this information from their public website. So important thing to note here, if you're building a real system compared to what I've set up here, your input and entry point into the system is likely going to look a little bit different. So going forward from here, kind of building off of this, once we have that URL as input, we're then going to move forward to using Firecrawl to go ahead and scrape all of the products we can find on this page. So we can grab that product name as well as the image URL of this first featured product image. This is going to be the image we want to animate, and so we're going to use Firecrawl to be able to go ahead and extract that from that public-facing URL. After that, we're going to do a little bit of data cleanup and then go ahead and use Gemini's API to call into the Veo 3.1 model to go ahead and generate a product animation. Veo 3's API supports passing in a reference image as the first frame you want to be featured in the video and the last frame. And so we're going to actually go ahead and take this image we're pulling from the public facing website, pass that into Veo 3's API as the first frame and last frame, and then give it a prompt so it's going to animate this model, striking a couple of different poses and maybe even spin around to show the full article of clothing. That is a new feature in Veo 3.1 and it's something we want to take advantage of to give us some consistent images that sets up a nice loop when somebody is previewing this on a public facing website. After that's done, we're going to take our final video as output and simply upload that into Google Drive and repeat over each of the other images we were able to extract from that North Face website or whatever URL we passed in. With all that covered, let's go through this automation node by node. So starting with our trigger here, we're going to see that we have a simple form trigger configured, the built-in n8n form trigger, and we have a single field defined within this form. We're calling it URL. It's going to be a text element, and we're going to go ahead and leave a placeholder here just to prompt the user to enter a product collection URL, which is once again one of these public-facing product collection pages on a D2C brand or an e-commerce website. I'm going to mark this as required because our system can't do anything without that, and that is going to cover the setup here for our initial form trigger. I'm going to go ahead and execute this so we can see what the input and output data looks like across this whole automation, and as we're going into some of these other nodes. The next thing we're going to do here is actually make use of the Firecrawl community node to get up and running with our scrape operation we need to perform on this URL we just passed in. So on the left-hand side here, we can see we have that exact same North Face URL getting passed in as input. We're going to be using this built-in Firecrawl community node. And so if I search Firecrawl here on the left-hand side and you have community nodes enabled, you're going to see it appear here. If you don't see Firecrawl, you need to go into your settings on the admin dashboard in your n8n instance and make sure you turn on the checkbox that says to enable community nodes. Let's go back to n8n here and pull up this Firecrawl node to see how we set up this request into Firecrawl to go ahead and scrape this data. That's going to be easy for us to use and push through the rest of our automation. So the first thing we have to configure here is our credential to connect with the Firecrawl API. I already have my credential set up here, but if you haven't done this before, it's very easy to get set up. So go to create new credential. We'll just call this Firecrawl account for now. And the only input we are going to need to provide here is going to be our API key. And so if you go to Firecrawl, go to the dashboard, all you need to do is click on this copy icon right here on the right-hand side after you sign in to grab your API key, and then you can paste that back in here and click save. I'm not going to do that now since I have my credential already set up, but once you click save and come back here, you're going to be able to select Firecrawl account or whatever you named this from that dropdown. Once that's done, you're authenticated to Firecrawl and you're going to be able to make authenticated requests going forward. The next step we have to configure here is going to be the operation we want to perform. Since we're trying to scrape data, we're going to be using this scrape a URL and get its content operation for the built-in Firecrawl node. This is going to call into the Firecrawl scrape endpoint. And so if I pull up the docs, we should be able to easily find this to see what's happening. So basically, the scrape endpoint lets you turn any URL into clean data. And just expanding on this a little bit further, Firecrawl converts web pages into Markdown, ideal for LLM applications. So Firecrawl is an API that makes it very easy to get structured data extracted from any website on the internet. So highly recommend it. I'm a big fan, and I use it for everything I scrape with. So underneath the scrape operation, once we have that selected on the dropdown, the first required property we have to pass in is going to be the URL we want to scrape. I'm simply going to use an expression here and do $JSON.URL to go ahead and grab the URL output from my form trigger that got set up from before. So we're going to dynamically grab that URL and pass that page in to be what we want to scrape. I'm going to go ahead and then leave parsers as empty since we're not trying to parse any kind of PDF document or anything else like that. That's a little bit of a more complex workflow. That's not relevant to us for now. But when I go down below, the one thing we do need to configure is a format here. Since we're trying to extract structured data from this web page, we're going to try and extract the name of the product for each product on this page and extract the image URL for each of these products as well. We can set this up by providing a format here to the Firecrawl API request we're building by specifying add format, select type as JSON, because we're going to define the schema of the data we want to pull out from this web page. And that's going to let us specify both a prompt and a JSON schema object of what we want to extract. So let me show you the prompt here first that's going to get included with the Firecrawl API request. Extract an array of products from this page. For each product, you must extract the exact image URL string as it appears in the HTML source code. Look in the image tags source attribute or source set attribute and copy the complete URL exactly how it is written in HTML. Include the full domain, path, file extension, and all query parameters. Do not modify, shorten, or transform the URL in any way. So this is a little bit lengthy for what you may expect to be able to extract this URL, but a lot of these e-commerce websites, when it comes to scraping, are working with something that's called a CDN. So if I just open this image in a new tab, we're likely going to see this pretty complex URL that gets built out here, where we have format set to auto, we're specifying the width, the height, any other processing happening on the image, and sometimes that appears as a query parameter. And so it's not as a simple image URL that you may be used to seeing on other websites. And so that's why I have this a little bit more lengthy and complex prompt in order to extract this here. So I do recommend you keep this in place exactly as I've built this out, as I found this to be the most reliable to go ahead and extract those image URLs. Let's go to the next section here, which is going to be the schema we defined for the data we need to extract. Since we're looking at a list of products on this collection page, the first thing we're going to do here under our properties option here in the schema is define this array of products. I'll give a description here. So list of e-commerce products found on the page extracted from the main grid or list of products. So we're going to get our list of every single thing we were able to find on this page. Then jumping into that array for each of the objects we're extracting, so we're looking at multiple objects found on this page, we're going to then have two different properties on each of these objects. First is going to be the title, and so this is going to be the product title or name that we are hoping to be able to pull from right here. So we have our woman's short jacket, this retro vest, and another jacket. We're going to look to pull that information out. And then the big one here is going to be the main image URL for each of these products. And so this is, once again, can be a little bit of a lengthy description, but just by getting this specific, we're making Firecrawl's job a little bit easier to go ahead and extract this, and it makes it more reliable for whatever scraping we're doing. So this is going to be the main product image URL. Look for the image tag within the product container and extract the full URL from the source attribute. If the source is relative, meaning it starts with a /, look for the absolute URL in the data source attribute, or the first URL in the source set attribute before any space or comma. It must be a complete URL as it appears in the HTML. So you don't need to worry about the specifics of everything happening here. I found that this prompt is pretty reliable for extracting the URL. This should cover your bases for any image URL extraction you need to do. Going down a little bit further, we're going to go ahead and mark both the title and the image URL as required, just further signaling to Firecrawl that it is important we need to extract this information. And then at the bottom, as we move out a layer higher, we are going to mark our products array as required, signaling to Firecrawl that we are always expecting an array of products to appear on the page that we're currently scraping. So depending on your use case here or how you're actually scraping this information, you may need to add more information. I highly recommend you look at the Firecrawl docs here and go to the extract structured data section to get more examples here on how you can work with the Firecrawl API for structured data. So that covers the main setup here for what we need to do. I also include only main content option set to true here because I don't care about the header or the footer on this web page. And then the rest of this information is left as the default. So that looks good. And then as we can see, this node is already run. And so if I expand our response here underneath JSON, we're going to see that we have our list of products or an array of products returned. And then we have our title and URL for each of these images. So if we pull one of these up, we should see that we're able to load this image as we expect. So that looks good, and we're able to continue forward to our next steps here. The next thing we're going to do is a little bit of data cleanup, where we're going to go from our single array into multiple items by using this split node. And so all I'm doing here is passing in data.json.products to go ahead and map to this array of products. And then we're going to be turning this single array into multiple output items. And so we have 12 items returned here as output, and that is matching what we're expecting when we later need to split out and loop over each of those. The other thing I have here is going to be a limit node. And so I can search this from the right-hand side. So limit or restrict the number of items. Because Veo 3.1 video generation is a bit expensive and there are some rate limits around this, I have this simple limit set up here for this demo, but in a real production use case, you're probably not going to have this and will want to remove it. Once again, this all ties back into what are the needs of your client or for your own business. And so for this demonstration, I'm just limiting this to 3 items returned. Let's move on to these next block of nodes here, which is going to be the main loop where we iterate over each of these products that we split out that were previously scraped and start generating these videos one by one using the Veo 3.1 API. The first thing we have set up here in order to actually loop over them is going to be this loop over batches node. And so if you search for loop here, you're going to be able to see loop over items split into batches. And anytime I'm working on something where I need items to be processed one by one in complex workflows, I use this and set batch size to 1. That means for all items that get inputted here, meaning 3 items after we filter this down, we're going to run every single node that we see here in sequential order, one after another. And so for product number 1, we're going to go through this full chain of nodes here. Then we move on to product number 2 before repeating that over and over again. So whether you have 50 items here returned into this loop, or you have the 3 that I filtered down for now, it's going to repeat for each of those items. And so when we enter this loop for the first time, or for the first item we're trying to process, the first thing we're going to do is go ahead and fetch the raw image URL that was previously scraped. And so we're going to open this up and see that this is a simple HTTP request node, like this, set to a GET request. And so all we do here is specify this as GET from the dropdown. Underneath the URL, we're going to specify the JSON.image URL that was previously scraped from before and split out, and leave everything else as default. So we can see here on our output that we get a single image returned, and it is a binary image returned from the response. n8n handles that for us, so we don't need to deal with setting any of these headers, query parameters, or body. All we got to do is pass in that URL. With that image in hand, the next thing we have to do here in order to work correctly with the Veo 3 API and some of the other nodes like uploading to Google Drive is convert this to base64 and then back to binary. Veo 3.1 does require a base64 string for any images that you're passing into the API, and so that's going to be the first thing we do here. All I'm going to do is you set this to data as our input here, which is the output of our previous node set to data. So we're going data as output into data as input here. And then we're going to just go ahead and output data once again. I know that was a bit complex, but basically we're going from this n8n binary file, which was our image previously downloaded, and we're going to turn that into a base64 encoded string, which is basically that exact same image data represented as this kind of garbled mess of letters and numbers we see here. All of that information from our image is present here and is going to allow us to later pass that off to the Veo 3 API. Now, because we actually want to upload this source reference image into Google Drive, we're going to go ahead and use another node here to convert this back into the native n8n binary file. And so if you search file here on the right-hand side, there's going to be the extract from file and convert to file nodes. We just used extract from file to convert binary data to JSON, and now we're going to convert this back to binary data using the convert to file node. Once again, we're going to take our base64 input field as data, which is that string of kind of garbled numbers and letters from before. We're going to put it in a new output file that's going to give us that exact same image we just downloaded. So this may seem like kind of an overstep right now, but this is the best way I've been able to work with binary files and n8n. The next node we have is going to take our binary file and go ahead and upload that source image to Google Drive just for us to build out a repository for everything that was scraped. So I'm using the built-in Google Drive node right here. I have my Google Drive account already connected, and so I'm going to use the file resource, the upload operation, and I'm once again going to take that data file as our input here for the file that needs to get uploaded. I simply call this source image and then give it a dynamic number here by using the built-in $run index. I add 1 since run index always starts at 0. And so we're going to see a number of files named source image 1, source image 2, and source image 3 that appear here in Google Drive. For the folder I want to save this in, I'm using the parent folder, the by URL option, and then just pasting in the link of the URL that I want these to get saved to. So just like I mentioned, we have source image 1, source image 2, and then as our third run comes through here, we're going to see source image 3 appear again. Now, the next step is to make use of this image and call into the Veo 3 API so we can get our fully animated product photo featuring whatever model was already in that image we just scraped. So I'm going to use a set field node here, and so I can keep my prompt all in one single spot. I'll pull this up, and then we can see how this prompt is configured. So I'm going to have this say, generate a video that is going to be featured on a product page of an e-commerce store. This is going to be for a clothing or fashion brand. This video must feature the exact same model that is provided in the first and last frame reference images in the article of clothing and the first and last frame reference images. In this video, the model should strike multiple poses to feature the article of clothing so that the person looking at this product on an e-commerce website has a great idea on how the article of clothing will both look and feel. And then under constraints, I just defined a couple of things I want to make clear for the video generator. And so no music or sound effects in the output video, really just want the animated product. The final output should not have any audio, and just building on that further, because this is something I had a little bit of trouble on consistently getting muted audio. That's something that's kind of a known issue right now with Veo 3.1. And so you may have to tweak this prompt a little bit depending on if you want that music, audio, or not. The other thing to note here is this prompt is specifically tuned more for a fashion or clothing brand. And so if you're doing something that is not for one of those, you may need to make some adjustments here in order to make this final animation make more sense for what you're trying to feature. After we have the prompt set, we're then getting into the main request into the Veo 3.1 API to go ahead and generate this video for us. And so we're going to be using just a simple HTTP request node once again, but this time we're going to be making a post request into the Veo 3 API. So the Veo 3.1 model is actually hosted underneath the Gemini API. And so any credentials you've set up to use this and the base URL is all going to look similar to other API requests we've made into Gemini. This is underneath generativelanguage.googleapis.com, v1 beta models, and then we're going to pass in this string here to go ahead and tell the API we want to use Veo 3.1. So it's Veo 3.1 generate preview, and then followed by a colon, we're going to use the predict long-running operation. After that's done, it's time to move on to the authentication section for setting up this HTTP request. I already have a generic credential configured here hooking into the Gemini API, but if you've not set this up for yourself, it's pretty easy to get up and running. All you have to do is come over to aistudio.google.com, click on Get API Key, and then click on this Create API Key button to go ahead and get that key. So we'll give it a name, n8n test here, and then you'll have to go through the setup steps to get connected to a Google Cloud project. After you click that, you're going to be able to see your API key value and go ahead and copy that to your clipboard. After you have that, you can go to the API Quick Start here, and then you're going to be able to see what the requirements are to set up an authenticated request. So if you scroll down a bit, you're going to see this REST tab right here for the first API call. And then under this -H, this is going to be how authenticated requests get configured to the Gemini API. We need to specify this x-goog-api-key value as a header, and then we're going to go ahead and paste in our Gemini API key as a value. So let's go ahead and set that up in a new credential. Coming back to n8n, you need to select generic credential type. Since this is going to be a header authenticated request, select underneath generic auth type, go ahead and click on header auth. And then we're going to go ahead and create a brand new credential. So we can just call this Gemini auth. We're going to then come back to our Gemini API Quick Start and copy this value that says x-goog-api-key. Paste that in as name. And then under the value, you need to go ahead and copy and paste that value you've set up from before under Google AI Studio into here. And then you're going to be able to save this and authenticate any requests you need to make to Google Gemini's APIs. So I already have mine set up here, so I'm not going to save that. Make sure you select your Gemini auth here that you just set up in order to authenticate that going forward. The next part of the request is going to be how we pass in both our prompt and those reference images we specified from before to call into the Veo 3.1 AI model. So I'm going to check on send body. I'm going to use JSON as the body content type. And then I'm going to specify body as using JSON. Underneath this new JSON field that appears, we're going to use an expression. I'll pull this up, and then we can see what the full JSON looks like on how we structure our request here. It's split up into really two different parts. One is going to be instances. This is where we pass in the dynamic data that's actually telling the AI model what it needs to do. And then the second part of this is going to be an object called parameters, where we do give the AI model a bit more config on how the video needs to be structured that we want to get back. I'll start with parameters here, as this is a little bit more simple. And so we're going to see that we want an 8-second video underneath duration seconds. We want a 9:16 aspect ratio, which is going to give us a vertical formatted video like on iPhones or short form video. And then underneath person generation, we're going to use allow adult just to signal to the AI model that it is okay for people, specifically adults, to be included in the generated video. If you have any kind of restraints here, I do encourage you to dive into the documentation for the Veo 3.1 model, as there is some more config you can look into further. All these docs can be found on the ai.google.dev website. And then if you come underneath models and click on Veo, you're going to see all of the different options that appear here under Veo API parameters and specifications. So I'm just using this simple setup for now for an 8-second video on this vertically formatted mobile video. The next thing I want to get into is going to be this array called instances, is where we pass in some of the more dynamic data that is needed in order to prompt the model and give it a first frame and last frame reference. Starting with the prompt, this is the most simple one. This is going to be our text prompt we built out from before, where we're asking the AI model to go ahead and generate an animation of the product we just passed in. So pretty straightforward. It's just going to be a string, and I use JSON.stringify here just to make sure our output to this is valid JSON. The next two are a bit less straightforward and are specifically supported on the new Veo 3.1 model that was not previously possible. This is going to be the image parameter and the last frame parameter. Image is going to be the starting frame reference image we pass into this model that is going to be the very first frame of the final video we generate. And then last frame is going to be the very last frame that we want to exist on the video that gets generated. And so in our use case where we're trying to make an animation where it is the reference model starts, showcasing their article of clothing or maybe spins to feature the clothing a bit further, by passing in the first frame and the last frame here, we are going to tell the AI model to generate a video where that model ends up in the exact same spot. And so we're going to see a very smooth animation that plays and can actually loop back to its original starting place on whatever e-commerce website we're hosting this. So that's the reason why I have included this last frame here. In order to pass images into the Veo 3.1 model, we do have to specify an object here, so underneath image, and that is going to include MIME type and our bytes base64 encoded value. Going back to our previous node where we converted our image to a base64 string, that is going to be where we use the output of this and pass that into our generate video request. And so we're just going to go ahead and grab the output of that node. And so node convert to base64.json.data. We're going to pass that exact same base64 string into both of these spots here in order to ensure our starting frame and last frame both are exactly the same. So that covers it for the Gemini API request. And the next step here is to fetch the status and go ahead and download that video when we know it's ready. Because generating video does take a fair bit of time, we're going to be making use of a process called polling here, where we continuously check the Gemini API to see if this video is done generating yet or we're still waiting on it. The output of our generate video response here is going to give us this partial URL we can go ahead and grab and check the status on. And so we can see here at the end, this says operations slash some random string characters here. That's going to be the ID of the generation we just kicked off. And so we're going to use that after waiting a few seconds to go ahead and fetch the status of that operation by calling a simple GET request into this URL we dynamically build out here. And so it's that same base URL we've defined here. We're still calling this Veo 3.1 generate preview. But then at the very end, we're looking at this slash operations slash that same ID we just got from before. Based on the response, we're going to be able to tell if this is done or not. We can see that we have a response that now appears here because that operation just finished. But if it wasn't done, we're not going to see any type of response that comes back. After we fetch that status, we're then going to use this if node to go in and perform a conditional check to see if this video has completed successfully or if it's still processing. So let's go through the first case here where it's still processing. We're going to look at our conditions we've set up where we're seeing if the JSON.response object exists. If we only get back name here in our response, we're going to loop back here and continue waiting a few more seconds before we check that status again. So if there's no response included on this object we're getting back, that means the processing is still underway. Same thing here with our JSON.response.generated videos response. If that does exist, meaning our response does exist, and we look one property deeper into this generated video response object dot generated samples, that means we have our generated samples back, which is the video we wanted to generate that has been returned to us, and we're then going to be able to go ahead and download that. So if the response is true and we have generated samples, that means we're able to go forward in this true part of this if check and go ahead and download that video. Otherwise, we're going to keep waiting until that processing finishes up. So going back here to the download video node, this is breaking out of our conditional check. The object and response is true, which then means we can download our video. This is going to be a simple HTTP request where we make a GET request to this URL that was returned. And so we see our response.generate video response, and we have samples here that are returned. That is going to give us a URL here that we're able to download and includes our full video. So I click play. We're going to see that our video is playing and it features our model actually demonstrating our article of clothing, striking a few poses, and is doing a 360 so they end up in the exact same position as before, based off of the first frame and the last frame we just passed in. And so this is a perfect video we can feature in loop on our e-commerce product page or on the product catalog or anywhere else on our site, just to give our users a little bit of a better idea of what this article of clothing is going to look like when somebody wears it. So we got our final video here. It's a binary file actually downloaded in n8n. The final step for this single processing of an input image is going to be uploading this video into Google Drive. So once again, we're going to use the file resource upload operation, and we're going to be taking in this data file here on the left-hand side as our input. So this works for images and for videos, and we're able to go ahead and upload that. We're going to set file name as output video number, where we're once again going to use run index +1 to give it a good name, like output video 1, output video 2, output video 3. And we're going to specify the folder URL we actually want to upload this to. If I open this up, we can then see we have our output video here, which is the same thing we just generated. That completes one iteration of our loop here for processing a single product we were able to scrape from that catalog page. Like I said before, what we're going to do after that upload finishes is come back to our loop node here, where we move on to the next batch to go ahead and process that next product we're able to extract. So all of those steps are going to repeat one by one for each of the products we passed in.
All right, before you go, make sure to hit the like and subscribe button. Seriously, do it, because we're going to be breaking down all of the AI automations that we use to run all of our businesses. They're super helpful, and we're going to break down exactly how we do them on this YouTube channel. So make sure to like and then subscribe, and then you'll get notified when we publish new workflows that can make your businesses run 20 times more efficiently, just like we're seeing here at the recap and the other businesses that we're running. The other item is join our school community for free. The link's in the description. You'll be able to get this template, this automation that we just ran through in this video, completely for free. You can go to school and navigate to the video that you want, and then you can download the JSON output for the n8n automation. With that, you can upload it into your n8n, clone it, and then tune it for your business and your use cases. So like and subscribe, join our free community to get this automation for yourself, and we'll see you in the next video.